Hello, my name is Mona, and today we will be talking about using hydrogen gas as a renewable energy source. Over the years, humans have used countless amounts of fossil fuels to produce energy, and because it takes millions of years for them to form, they are considered non-renewable and are expected to run out. Because of this and the pollution it creates, which causes climate change, renewable and cleaner energy sources like hydrogen energy must be considered. Many people have tried to collect, store, use hydrogen for energy, but most people have failed, and the ones who were successful found the materials to be expensive and have had trouble with measurements as well. Dr. Xiaobo Chen worked with other doctors, and together they were successfully able to capture hydrogen through photocatalytic hydrogen generation, which uses metals and semiconductors to excite electrons. They also used dye-sensitizing solar cells, where a dye on the nanomaterials captured photons and created an electric current. Titanium 2 dioxide worked best for this, but it is very expensive. Researcher Wang Ju Qin wrote a paper on how easy it is to make crystallized sodium aluminum hydride, which can capture and store hydrogen. But the materials are still expensive, and if capturing hydrogen is expensive, then the hydrogen itself is going to be expensive. In order for, fuel cells, first of all, were invented in 1839 by Sir William Grove, and they were basically making electricity based from chemical reactions. The machine took in hydrogen and oxygen, and it created an electrical current, and the only byproduct was water, so that's good, less pollution. In order for a fuel cell to continue to work, though, it needs an ongoing amount of hydrogen going in. It needs proper storage. We also need ways to measure stored and converted hydrogen energy. Some scientists have already started this, but they've started using fundamental math laws, and a lot of work needs to be done, as Chris will explain.
Thank you, Mona. As she said, I'm Chris, and our purpose for doing this research is to identify variables that haven't been accounted for in current mathematical models. We're going to observe how, when we implement those variables, how they can affect hydrogen production and energy production as a whole. Now, our main research question is, what are these variables that we have not been accounted for in hypothetical mathematical models? The main one we're going to be focusing on is nanomaterials. So our hypothesis is, if nanomaterials are accounted for in these calculations, they will end up increasing the hydrogen production and overall energy output as a whole. Now, how we're going to conduct our research is we're going to be using a mathematical model developed by Solomon and Marchenko. Now, their mathematical model relied heavily on electrolysis, and what we're going to do is use nanomaterials rather than conventional electrolysis. One way we're doing this is by using compressed nanoparticles, and we're going to be using them as the actual electrodes in the electrolysis. Another variable that we have is using nanomaterials that are coated with special dyes that will absorb solar energy, and we can create hydrogen that way, and we can observe how the energy production varies with that change. Now we're going to implement both of these variables into the equations that they created, and we're going to see how the energy output changes. And to wrap up, Michael Palacios.
Now there's three things when thinking about responsibilities of researchers. There's ethics for individuals, laws, and then code of ethics for the profession. For us, for our personal ethics, we chose the common good approach because we believe that this will affect everyone as a whole, the society, the world. Also, for an ethic, misappropriation of data, we would have to request to use certain researchers' mathematical models or their experimental data so we can work on them or just look at them and hypothesize more. And then laws and code of ethics for profession, they're very, very close together, so I put them together. They're both overall in the same thing in 1910.103 by the United States Department of Labor. This talks about delivery, usage, handling, and storage. They go very specifically, such as in delivery, there has to be a certain driver, has to be certain containers, no flammables near it. For usage, it has to be proper handling, has to be in the correct environment, safe, And then for storage, it's same with delivery. It has to be in proper containers, no flammables, and it goes on from there. Now the benefits for our entire proposal is hydrogen would be a reliable and longer lasting energy source for the world. It would be able to power third world countries, second world countries, first world countries. It would also provide us a cleaner atmosphere instead of fossil fuels like Mona said. We would be replacing those with hydrogen as our main source of energy, which would not only be cleaner, but be more efficient. And finally, for the last benefit, we'd find holes in hydrogen math models, like from Solomon or Marchenko. And from there, we would hypothesize and put variables such as nanomaterials and different ways of nanoparticles into those mathematical models and predict from there. Or we would leave it up to other experts in the field to do that. Thank you.